It's an LED streetlight. Fortunately, it's a small LED streetlight, so it does actually fit in the bench. This is an Indo Air 1, and I'll give you some of the specs for this light, then I'll show you it lit, and then we'll take it to bits. So, it is an Indo Air 1 Road, and its main features are direct drive technology. I wonder what it meant by that. Turns out the electronics are on the actual LED panel itself, what we'd call a DOB, driver on board. There is no driver actually in the base here. Low windage, what that means, it's got low resistance to wind. Lightweight fitting, it's definitely quite lightweight. Not super lightweight, but these things are solid aluminium, so they're always pretty hefty. They have to be. No hinges, clips or lids. I kind of wish this one did have a hinge, but it doesn't really matter. I can understand where they're going here. Integrated long life photocell. In this case, it's got a socket in the back, a NEMA socket for photocells. Excellent thermal management, fully sealed. And it does quote a superior lifetime of 230,000 hours. Quick and simple to install. It looks fairly straightforward. Yep. Right, tell you what. When we go inside, this one is rated about 18 watts, I think. But they're apparently available from 5 to 35 watt. The control for the dimming, you can get it a preset intensity. I'm not sure what it means, preset dimming here. I don't know if that's just a switched input. But it's also got the DALI control, which is a network control, and I'll show you that in a moment. What else has it got to say? Reliability, 0.58 failures per million operating hours. Sounds quite good. And there's the 230,000 hour rating. Oh, risk group LG1 for the LEDs. What that means is it's not too damaging to the eyes unless you're right up against it. And then it's got a couple of photometric patterns available depending on the application. Okay, so this thing is designed to clamp either on top of a pole, a straight vertical pole, with these grub screws at the side, and the typical size will be 76mm, but these go in quite deep. And I also notice that this bracket at the bottom here can be moved backwards and forwards. Don't know if you can see that. Where's a little source of light? I had a little source of light. If you take a look in there, there's a little bracket in there that can be moved backwards and forwards. I think that may be a way of changing the angle just slightly of the light. You also get adapters for different size poles like this that can actually be sat in, and then they get clamped onto the pole, and the thinner pole, and then these get clamped onto it. The other option is for a pole. I think it's rated for a 60mm bracket coming off the top of the pole in the side here. Not quite sure what the clamping system is here. I think it just does rely on these two grub screws centering it up. Anyway, let's show you it lit. I'll put them down there. Now on the back we have the NEMA socket. NEMA is an industry standard. I'll just not demolish the place here. NEMA is an industry standard for the photocells, and this is the one it came with. Normally, the traditional photocell just has 3 connections. It's got a big neutral connection, then it's got live and switched live to the load. But this one has the extra 4 connections, which are 2 for Smart City network and 2 for the DALI network. Both of those are lighting control networks. Now, because I'm going to be trying this out right now, I'm going to have to put in a shunting plug. What this does is it basically just bypasses that. It's worth mentioning that this has none of the networks on it. It's just purely a relay to switch the light on and off. And the light doesn't just light up instantly. It's quite interesting. So I'll put that shunting plug in, and this is where it's not going to get super bright because it is a fairly low level street light. I shall hold this back here and I'll plug it in. You'll initially see a flash as the circuitry activates, and then it will come up. It will actually power half the LEDs and then the other ones, then it will ramp up. Are you ready? They all seem, did that actually do it? Hold on, I'm going to try again. No, this time they all came on together. Oh, that's interesting. I wonder why that is. Oh, I wonder if it's... No, I don't know if this has any sensing itself. Maybe this does have sensing. I don't really know about that. Let's bring in the hoppy. What if I turn the light off? Let's do that and see what it does. So I shall plug in the hoppy meter and I shall turn this light off. And I could take the exposure off, but I'm not going to because otherwise it's going to be dazzling. I'm going to plug it in. No, it just lit up full brightness. And it's showing 9.9 watts. I wonder, and I did notice its behaviour before. It would, and now it's dimmed down to half intensity. It's dimmed down to 4.6 watts. And now it's gone out. Why? Does this have dusk sensing built in? I guess we'll find out when we open it up. I'm going to turn this on again. No, it did light up full intensity again. I don't know if there's any other sensing here. This is strange. Anyway, right. Let's explore it. Watch your eyes. The light is coming back. I mean, it's been coming back quite a lot with this light. But here it is again. There we go. The maximum I've had it at was about 16 watts. Just knocking stuff everywhere because this is quite a big bulky light. Yeah, I wonder what's going on there. Anyway, there is a connector in here to facilitate just hooking the flex up with a simple connector, but unfortunately it's marked live W neutral, but unfortunately the neutral is actually the earth, and inside, well, I'll take this cover off and show you. So I've already had this off because it has a thread lock on the screws, and that was just making it difficult. Bit of noise. So this comes off to reveal the gear tree effectively. And the gear tree, the most notable things in here are the connector. Notice, I'm just going to take this photocell off the back. There we go. Notice that it's marked live, neutral and earth. In reality, if you look at the terminals here, the live is the only one that's right. The neutral is the next along and then the earth, and that's how it's marked. It's not actually marked on the other connector that way. It's kind of weird that they've done that. We have these connectors in here going to the LED panel, and we've got a little fuse surge suppressor. And they make a thing about the fact that these units can be fairly easily serviced. I think what they mean by that is this panel can be removed. Let's remove the panel. I need to have a tidy up here. It's getting very cluttered. So to remove the panel, you take out these 4 corner plates. We try and do this in a fairly controlled manner without scattering hardware everywhere. And once those brackets are removed, the light module itself has a cable going through a channel into the main body here. And there's the port for it. There is no heatsink compound under this, but it is a very thick aluminium plate. See, they make a thing about this being serviceable and easily changed, but the easy to remove terminals are the ones here that they've actually used at the factory, so to speak. And the actual module is pushed into one-way trip connectors. I don't think these are going to come out. But you do have a couple spare, so you may have to cut them flush and actually just push them in. So honestly, I think the reason they say it's serviceable is purely so they can tick the box of eco. I don't think people would service these, because when you weigh in the time factor versus how someone just basically going up and planking a new light fitting on top, if they really wanted to service these, it would be worth taking them back to the workshop. But let's see if I can get the module out. I'll take these screws out. Is this going to fit in there? Okay, let's take those out as well then. Because this is a little chassis plate. Or chassis plate if you're in America. That supports the connectors. So to be honest, I think I'm going to have to cut those wires to get this out. I don't think I'm going to be able to release them from there. Rightio, well, so be it. I shall cut them then. I notice the 2 connections. We've got grey and purple. And they're going up to the the socket here, so it is DALI on the input to this. So let's cut these. Maybe not the official way to do it, but it's the way to do it right now. I'll cut that one as well. If I actually had a load of these to change, I might consider, as an alternative to this, actually using a little inline splice connectors for the new light and just maybe taking this out and cutting the wires, but just leaving them inside and tucking them up where the other wiring is. Is this going to come out now? It has a bit of heat shrink sleeving on it for extra protection. And here is our module. Don't know what that is. It's sticky. Ugh. Right. Now we're here. Oh, I know what it is. Or is it? This is where they've done their best to seal as much as possible, because this, anywhere that water can get into this, that's a likely source of failure, because water does creep in. It gets in everywhere. But I tell you what, there are quite a lot of screws here, so I'll pause briefly while I undo them. 1 moment, please. The screws are out. What is it going to show? That is quite a well-packed circuit board. I mean, it's not super mega packed, but it's got a lot of specialist stuff on it, hasn't it? That is very intriguing. Interesting seal as well. The seal has a thermal pad in the back. There's the thermal pad that's going to dissipate most of the heat into here. And what are these little black things for? Is that just for alignment? Or something else? Not really sure. Anyway, I shall take a little image of this and we can take a closer look. 1 moment, please. And resume. And that 1 moment, please, was 4 hours long, and I still don't have all the answers, but I've got enough to show you what stuff does on here. The power supply has got me perplexed. Another thing I didn't mention, the thing does come with the Indo glands, yeah, well, seals. And when that's put in the main post-mounting hole, what I mentioned earlier about the 76mm post top, this is that 76mm. So that answers that. The circuit board itself is exquisite. It's really neat. It's very much an integrated system. There's also a little coil in here. Is that visible there? It's not really visible here. There is an embedded coil in this, possibly for external programming, but the chip that's associated with it isn't actually on the board. It's that little chip that's missing there. I'm going to zoom down a bit here because we want to get more details in. So we get these clusters of chips, LED chips, and these appear to be multi-chip LEDs for a higher voltage. And they're not just all in series in these clusters. They're actually staggered. There's like 4 and 4. And also the LEDs are alternate on a different driver chip. That's these 2 chips here. The ACRICH 3, more about that later. And that correlates. I didn't realize this before. If you look at the lens system, the LEDs correlate to the pattern, so you can actually theoretically choose via either programming it in from the factory, presumably with these program pins here, or possibly via the DALI interface here, the digital interface. You can actually theoretically program the beam pattern of this. That is pretty clever, is it not? Very, very interesting. The circuit board is not an aluminium core circuit board, which is surprising, and it may be multi-layer because it is complex. And believe it or not, there are plated through holes, but you can't see them because they're kind of full plated through holes. And each of these LEDs has a fin going out from it that couples through plated through holes onto the other side. And then when you look at what that was on, let me just grab it, that aluminium plate. It has this thermal coupling pad to then take that heat. Those little black studs, they were just for alignment of the thermal pad. It's a complex system. It really is very professional, very intriguing. Right, so let's explore the components. So the main supply comes on here. And it goes through the 5 amp time delay fuse, and the first thing it does is it not just goes to this bridge rectifier and gets converted from the AC to DC, but unsmooth DC, but it also has these 3 components. These are metal oxide varistors. Then a power supply is generated for a PIC microcontroller. Now, this power supply must be 2 voltage because the PIC microcontroller is going to be running at 5 volts, 3.3 volts, not sure. But it is controlling the ACRICH chips. These are dedicated LED drivers, but it's controlling with a 0 to 10 volt signal, which is kind of old-fashioned, but still very valid. This MOSFET here, there's 2 MOSFETs. This one, I wonder, initially I thought this might be what they call a switch capacitor buck regulator, but I'm wondering if this one is actually a protection MOSFET to protect against erroneous voltage issues, because it also feeds over to these 2 transient suppressors. Lots of transient suppression because, well, street lighting, it's a very electrically noisy environment, particularly when you put an LED fixture on a run with lots of metal halide, high pressure sodium, low pressure sodium. They've got high voltage spikes and things going on. You have to protect the electronic circuitry. It would be ideal if everything was just LED, but you can't really allow for that. So they include these extra components just for that extra protection. This MOSFET rather suspiciously gets quite hot, about 45 degrees Celsius. And it's worth mentioning that on standby, unlit, this panel draws 2 watts. Now, normally it would be switched by the dusk sensor, but it doesn't have to, because it turns out that the reason it wasn't performing as I expected is this is a little light sensor here, and if I power this board up with directly and the light is on above the bench, it will go out. It will gently fade out, and if I then turn the bench light off, exactly 1 minute later it will gently fade back on again. Turn the light back on again, it has that delay of 1 minute, and then it fades back off. So this is a light sensor, and you might think, how does it know? How does it detect if it's lighting up itself? Well, that you know, it's dusk or whatever, or daylight. Well, the answer is because the way these LEDs are driven, they're actually going off. In the case of UK, 100 times a second. In the case of America, 120 times a second. And it's obviously taking a little snapshot of the ambient light levels during that. But this doesn't mean there's flicker because of these ACRICH 3 chips. I wonder if these are also from the same stable, the LEDs, because that they do seem to be a common paired thing, and they do manufacture modules for the street lighting industry. But this is made specifically indolighting.com. So if we take a look at one of those chips, we can see that it's got the 4 sets of LEDs that are fairly high voltage. They add up to pretty much the mains voltage, but they're actually staggered, so that initially when it's at the bottom end of the sine wave, when it approaches, in the case of UK, probably about 60 volts, it starts turning this set of LEDs on, and as the voltage increases, then it turns that leg off and it turns this one on, and it basically the LEDs are sort of ramping up. But because they're actually spread evenly across the circuit board and mixed in amongst each other, you don't actually see that effect. And what that means is that they can achieve extremely good power factor. I mean, this thing is 0.9 power factor plus. It's like, I think it was 0.98 power factor. It was really good power factor, which is just means that it runs. You can run a lot of fixtures in one cable without having to derate the cable for inefficient power factors. But there is the analog DIMM input from the microcontroller. Interesting chips, DT3007A, was it? Hold on, let me just check that with a magnifying glass. These are the DT3007B variant. What else is there to say about this? I am perplexed at the power supply. That is definitely getting warm. Is it a linear regulator, or is it using switch capacitors? I don't see any. I could see possibly this being used as a reservoir capacitor for the power supply. Oh, is that a Zener diode? I didn't check that. These little chips down here, not sure what they are. They are labelled A89A. I drew a blank on that for some reason. I wondered, initially I thought they might be the digital, maybe a level shifter for the 0 to 10 volt, because I don't think the microcontroller, which is a PIC microcontroller, can provide that directly, but that could just be using transistors for that conversion. But let's take a look at the DALI. The DALI is quite interesting, the Digital Addressable Lighting Interface. So this is a popular interface in the lighting industry down here, and you can see it is opto-isolated. It's got two opto-isolators because it can communicate backwards and forwards. And if we take a look at the schematic of what's on here, which is a very standard DALI configuration, we can see that the first thing it hits is a bridge rectifier. In the case of this unit, it's using two pairs of diodes in sort of the SOT 23 type packages, little transistor packages, and that's a transistor, that's a Zener diode, and then 3 resistors, and then 2 opto-isolators. That's all there is to that. But here is the circuitry. The DALI interface is a very slow protocol. It can only transmit a small number of commands per second. It's not like DMX, but the upside of this is that because it's very slow and it uses very high voltage, about 16 volts for a data network, and a very sort of low impedance, it's literally powering all these LEDs when it's active, and when the processor wants to send data back, it just shunts out the network. But the idea of that is that you can use standard mains wiring, and you can run it in the same trunking or cable raceway containment, and you don't have to worry. You just use standard mains wiring for it, and you don't have to worry about the polarity because it is going through that bridge rectifier. That's so people can't mix up the network polarity and just, they made it idiot-proof, basically. So that converts the DALI signal for 16 volts, 250 milliamps, to whichever polarity it is, it will correct it, and it will be plus roughly 15 or so volts and 0 volts. And as long as it's above 5.1 volts and plus the voltage this diode sets, let's say this diode's probably going to be 1.5 because it's probably infrared, say 6.5 volts. As long as it's above that, that LED will light, and that's the optocoupler LED that sends data into the process, the little PIC microcontroller here. When the PIC microcontroller wants to send data back, it turns on its LED, which is probably one of the highest current bits, really, in this circuitry, because the PIC microcontroller is a very low current device. And those chips, those ACRICH chips, they just basically use their own power. They are very, very interesting chips. But when the microcontroller wants to send data back onto the network, it pulses its LED, and that literally turns on this transistor, which shunts the network. And all the other devices, all their LEDs basically blink off, and they can see that data is being transmitted. And it means that you can have a big long run of, say, you could have a common power source. If this was a traditional building one, you could have loads of light fixtures along it, plus you could have various keypads, or you could have passive infrared detectors, and they can be powered from that 16 volts, some of them, if they're low current, and they can put data onto it and say turn the lights on, and then later on they can say turn the lights off. But in this case, it's just used purely between a more intelligent head than this, probably one with a wireless network connection, to actually do more interesting things, also probably for programming this unit in the first place. Very interesting. Anything else to say about this? I think I've covered just about everything. I'm going to start exploring that again, see if that is a Zener diode. Certainly that was getting the hottest. I wonder if they're also possibly using, no, I'm not sure, current through the rest of the circuitry to actually take some of the load off the power supply. I just didn't see a dedicated power supply chip around here. I saw things, I know they sometimes hide as transistors these days. You get 3-pin chips that do just amazing things, but I couldn't tally up. This one is simply 330. That came out as a standard transistor, and it's just, you know, most of these things were not coming up in a search, to be honest. They were just drawing a blank on Google because they've used cryptic codes because of the small space that they can print in that. But there we have it. The Indo light. Surprising. When it arrived, I was expecting a separate driver inside. I wasn't expecting it to be on the circuit board. But here it is. Everything is on the one board, make it a very modular system. So yes, you can literally repair the fixture if it's commercially viable to do so by taking the whole module off this and connecting the 4 wires, power and the DALI network into the fixture, and then I'd bring the fixture down from the pole for this. I wouldn't try it up the pole. But you can then just refurbish the fixture almost completely. At the same time, I would change the transient suppressor. Hold on, let me grab it. Nice machined aluminium casing. This little fuse, they wouldn't do it though, would they? The average person wouldn't change that, but I would, because that's another layer of protection against transients. But here we have it. It's quite nice. It's a chunky thing. Very neat. So that was well worth exploring. I'm sorry I couldn't go further. I would have loved to give you a schematic, but really there are a lot of components on this board and it just wasn't viable, particularly when I'm struggling to actually trace out the power supply here, which was the main thing. But the real secret of the thing is the microcontroller, the DALI network, and the ACRICH 3 dedicated control chips for the LEDs and the LEDs themselves. So all in all, it's a very well engineered device.